Hello, good day. Um, Today, my name is Mr. Modulus. Today, we are going to continue with mathematics. So, our favorite topic today is algebraic fraction. Okay, so let's get started. All right, so um, we have on the board algebraic fraction. Of course, let's explain each and every one of them. So to understand the term algebraic fraction, we need to understand the individual words. Of course, fraction is generally defined as any term, any expression which can be in form of ratio of two integers. Let me say a and b, a over b, such that a and b come from a set of integer. That is, a and b are integer. All right. So algebraic there, or algebraic, is coming from the form of algebra. Algebra simply means any mathematical expression, mathematical terms, which include real numbers, symbols, alphabet, and all that. All right. So algebraic fractions are fractions in form of algebra. So example of algebraic fractions are, so we have example. So we have a plus b over c plus d, x squared minus y squared over x squared plus xy. Right? Okay, we have 4ab minus 9bc over 2a, and so forth. So any fraction having some mathematical expressions, real numbers, combination of real numbers and alphabets, are regarded as algebraic fractions. All right. So in a moment of time, we are going to go into simplification of algebraic fractions. Simplification of algebraic fractions. So we have here simplification of algebraic fraction. One thing in mathematics is that before we begin to solve a problem, before we begin to solve anything or any situation, before we begin to model solution to any situation, the situation must have been a problem. There must be a problem somewhere. All right. If there is no problem, there is no need for a solution. All right. So the essence of solving problems under this concept is because of some algebraic fractions are not in their normal state. They are not in they are in ambiguous state. So they needed to be evaluated in a way that they will come to their simple state. And that is the purpose of solving algebraic fraction. Just like we have been dealing with numbers. For instance, dealing with ordinary fractions, fractions of real numbers. For instance, we have 10 over 5. Of course, we can't leave this thing like this, because in as much as this is a fraction, okay, let me say 5 over 10, I think it's better off this way. In as much as 5 over 10 is a fraction, it's still not in its proper form. So it needed to be reduced to its simplest form. And its simplest form is we have to take off the common factors. The common factors between the numerator and denominator must cancel out. Okay, so here we have common factor of 5 here and common factor of 5 here. So we have 5 here 1, 5 here 2. So instead of writing 5 over 10, we have 1 over 2. And this is the actual simpler form of 5 over 10. So when we are in algebraic fractions, problems are given us in form of this way. So we need to put it in its simplest form, and that is where the solution comes in. All right. So in a moment of time, we are going to talk about some certain problems. Okay. So I have this one. Example. Simplify the following. Okay, so let's start with this. All right, like I said earlier, simplification of algebraic fraction is evaluating an algebraic fraction to its simplest form. And its simplest form is considered as its standard what form. So any fraction that is not in its simplest form is not the solution. So the solution should be the simplest form, right? So we are going to look at all these fractions and put them in their what simplest form. Remember, these are algebraic fractions because they are fraction in form of algebra. That is, they have some mathematical term, not necessarily number only, but a combination of numbers, alphabet, and symbols. All right, so let's go into details. So we have solution. So the first one we have in our custody here, right? Let's have a solution somewhere here. So we have we have mnu over nuv, right? Okay. So we have mnu over nuv. So this is not actually in its simplest form because there are some factors, there are some common factors here. We have n at the numerator, we have n at the denominator. They are common factors. We have u at the numerator, we also have u at the denominator. They are also common factors. Remember that even a term is a factor of itself. 5 is a factor of itself. So u and n are factors of themselves, so we need to cancel them out. And remember that once there is an existence of multiplication between the numerators and denominators, they can cancel out. But if they are not actually multiplying, if the numerators are not multiplying and denominator at the same time are not multiplying, you can cancel out until they must be in form of multiplication before cancellation can prevail. All right? So in a moment of time, we have a common factor of n and n, so we can cancel. We have a common factor of u, so u can cancel. So leaving over mv, and this is the simplest form at which this algebraic fraction can be. So here is our simplification, and that is the solution, and that is the final answer. All right, so we go over to the next one, which is II, which is 8x squared z divided by 10x yz. Of course, since there is a multiplication existing between the numerators and denominators, cancellation can prevail. All right, so we cancel here. We have common z, so z cancel out. All right, here is s squared. Of course, s squared is x times x. So if you have s squared over x, that means it's x times x over x. So x cancel 1x. So here x cancel 1x here as a power. So remaining only x. So here we have x here, 1x here, we have x. So leaving, okay, we are not done yet. There is a common factor between 8 and what, 10. Of course, 8 is 2 times 4, while 10 is 2 times 5. So both of them has a common 2, of course. So here we have 2, here we have 4, 2 here we have 5. So leaving over 4x at the numerator, so we have 4x here, and 5y at the denominator, 5y, right? So this is the common factor. Or you can also write it this way. You can write it as 4 over 5 x over y. They are still the same, all right? So you can write the number separate first before the alphabet. Okay, so we go back to the next one, and that is the solution. You cannot reduce this further. This is the simplest form it can ever be. So we'll go back to the next one, which is we have u plus m over u plus n. Of course, in as much as we have common term here, u and u, of course they cannot cancel because what that exists, the sign that exists between numerator and denominator is additional sign. All right? Is additional sign. The only way addition or subtraction can exist and yet cancellation can prevail is if there is a means of factoring out that which is common between numerator and denominator. whenever you factor it out, that number that you factor out will be in form of multiplication to the remaining term. So the multiplication will still exist between the number you want to cancel and the remaining term. So that is when you can cancel. But provided that there is no multiplication between, oh, I will show you the what I mean by that. Okay, let me put it here. For example, assuming I have AB plus A all over, let me say, all over AB. Okay, so here the only way I can, this is solvable in as much as there is an addition between the numerator. Of course, A can be factored out, right? So if I factor out here, we have A divide AB, A will cancel A, remaining B plus A divide itself is 1. All right, anything divide itself is 1, then all over AB. So you can now see that the common factor, which is A at the numerator, is now in form of multiplication to the remaining term, which is B plus 1. So there is an existence of multiplication between that term and the remaining term, between the common factor and the remaining term. So as a result, you can cancel. Not necessarily because of the additional sign, but because of there is a multiplication here in between the factor being factored out and the remaining term. All right, but here we don't have such. There's no such multiplication. So supposing there was a way of doing this, so we can have the common factor multiplying the remaining term, and here common factor also multiply the remaining term. Of course, cancellation can prevail. We can do the cancellation, but in the moment of time we can't. So because we can't, the lowest term here is still the same expression. So the simplification of this is still the same expression. We can't cancel out because of the existence of additional sign between the numerators. All right. So here the final answer is U plus M over U plus N. Final answer. So we'll go back to the next one, which is okay, IV. IV you have AB plus AC all over AD plus AE. All right. So we go back to this. Of course, there's an addition between the numerator and between the terms in numerator and terms in denominator. So we can't cancel anything. All right. So for we to bring cancellation in this situation, we need to simplify. I mean, we need to factorize this so that we can have an existence of multiplication between the term we need to cancel out and the remaining terms, both in the numerator and the denominator. All right. So now let's do that. Of course, the common term here is A and common term here is A. So we can factorize A here and factorize A here. If you don't understand clearly in this my factorizations and the evaluations here, you can go and watch my videos on simplifications of algebras. I mean, simplifications of mathematical expressions. All right. So you go and watch my video on that, then you understand better. So let's do the factorization here. Of course, what is here and here is the common factor here is A. A is here and A is here. So we put A outside the bracket. Remember, anything you want to factorize must be outside the bracket. And that which is outside the bracket is multiplying that which is inside the what? Bracket. So use whatever you want to factorize and divide each of the terms. So whatever that is left, or the result you got, or the quotient, will be written. All right. So here I'm going to use A and divide this term. Whatever I got as my result will be put in here. Then I'll put the sign. Okay. So let's do that. So A divide AB. So we have AB divided by A. Of course, A will cancel A, remaining B. So here we have B. What sign is here? Plus. A divide AC. So we have AC over A. A will cancel A, remaining what? C. So we have C and remaining. Of course, we can check whether if this thing is still true. It's true. So here, if you open bracket, of course, what is outside bracket is multiplying what is inside bracket. So A times B is AB plus A times C is AC. So this and this are also the same. Where the only difference between the two is that this one is the factorized form of this. So a process of transforming this to this is called factorization. And what do we factor out? The A, which is common. You know, you cannot factorize that which is not common. We only factorize that which is common. All right, so we divide. So what is common also? We have A common. So we bring the A outside. A divide AD. A cancel A, remaining D, plus A divide AE. A cancel A, remaining what? E. So at this point, we have factorized even denominator. We have factorized a at denominator. So if we check it, a times d, ad, plus a times e, ae. All right. So now, because there is the existence of multiplication between the term we need to cancel and the remaining term, both in numerator and denominator, cancellation can prevail. All right. So we can cancel now. So a can cancel a. So leaving over b plus c over d plus e. So our final answer is b plus c over d plus e. So there's nothing can cancel anymore. All right, there's nothing can cancel. Even though they don't have, even though that they don't have the same, there's no common term here. Even if they have it, we can still cancel because of the positive sign existing between the terms in numerator and denominator. Okay, so that is it. So we go back to the next one, which is the fifth one. We have h squared minus hk all over hk. So at this point, I hope you can do something. So feel free to do it. So you have a few minutes for that. Okay, so let's do it. So here we have, of course, we can cancel this way because they are of negative sign that exist, all right, between the terms in numerator. So we need to factorize what we want to cancel out. So there will be a multiplication between what we want to cancel and the remaining term, either in numerator and denominator, right? So let's factorize. So what is here and here? We have h common. So we'll bring h outside. H divide h square. Now remember that h square is h times h. So h square divided by h should be h times x over h. H cancel, we have remaining 1h. So h divide h square, we have remaining 1h. What sign is here? Negative. All right. So h divide h k. H will cancel h, remaining what? K. Of course, if you don't understand how I do it, hk divided by h cancel h, remaining what? K. Because we are using whatever we want to factorize out to divide each of the terms and write the result, okay? So if you open bracket, we get the same result, h times h squared. We have negative here, h times k, hk. All right, so all over hk. So at this point, this h is multiplying this k, so it's free to be cancelled out. So because of the existence of multiplication between h and the remaining terms in the numerator, and multiplication between h and the remaining term in the denominator, we can cancel out the h. All right. So we have h, we cancel h. Supposing there is addition here and addition here, a cancellation cannot prevail. But because that there is always a multiplication in between the terms, in numerator and denominator, such that it involves the one we want to cancel out, of course the cancellation can prevail. So our final answer here should be h minus k over k. So that should be our final answer in a moment of time. Okay, so we have this last one. So which is s squared minus 4x all over s squared minus 4. Okay, so we check what is common here. Of course, x is here, x is here. So we factorize x, all right? So x divide s square. Of course, s square is x times x. So x will cancel 1x, remaining 1x. So if you say what x times x, s square. So we have negative sign. X divide 4x. X will come and cancel itself, remaining what? 4, all right? So for those who doesn't understand it, so we'll go again. S squared divided by x. So we have s squared is x times x over x. So x cancel x, we have this x. Then negative sign. Then x divide 4x. So we have 4x divided by x. Remember, 4x is 4 times x. So x cancel x, remaining 4. That's how we got it. So here, this is of course, the difference of two squares. So this kind of questions can't be simplified enough, right? Because of the way it is being positioned. Now, let me add something here. Let me say 2 here. Okay, so if I have 2 here, let me have 2 here. Okay, let's put 2 here. Let's work with 2. Okay, so it will look like what I want it to look like. So now, of course, we can do something here. Supposing we have something like this, so I'm changing the question, changing the term. Okay, changing it 2x. Now, 4 here is the same thing as 2 squared. So I can write 4 in index form. Okay, I write in index form because 2 squared is 2 times 2, which is 4. So we can write this as s squared minus 2 squared, right? S squared minus 2 squared, where 2 squared is 2 times 2, which is 4. All right, so I want to put it in this form so that I can be able to maybe get something that might look like x minus 2 or something like x. All right, so now this call for the knowledge of difference of 2 squared. This is a term squared, another term squared, and there is a negative sign between the two of them, which shows difference. All right. So, and the principle of difference of 2 squared says that x squared minus y squared is equals to x plus y multiplied by x minus y. So, if we apply this thing here, we have that x squared minus 2 squared will now be x plus 2 into x minus 2. So we can substitute x plus 2 into x minus 2 with x squared minus 2x squared. So we can replace 2x squared, we can replace x squared minus 2x squared with x plus 2 multiplied by x minus 2. All right? So now let's go there. So this will now be equals to x into x minus 2 all over, this is difference of 2 squared, which is x plus 2 into x minus 2. Of course, if you watch my video on expansion, if we expand this, we'll get this. If you expand x plus 2 and x minus 2, we'll get this. Expansion means multiplication. So if we multiply this by this, we'll get this. So showing that we are accurate in whatever we do here. Now, if we expand this and this, we get this. So expand this and this, we get this, and expand this and this, we get this. So we are still on the same page. Of course, there is a common factor. So there is a multiplication between this and this, and multiplication between this and this. So any common factor can be cancelled out, all right? So of course, there's a common factor, x minus 2, x minus 2. So x minus 2 can cancel out with x minus 2. So leaving only x over x plus 2. And that is our final answer. Okay, nothing is common here, nothing is common here, so we have cancelled out everything that is common. Yeah, somebody will say, but there is common x here and common x here. Yes, you are not far from the truth, but the point is there is a positive sign between x and 2 here, and because of this positive sign, this cannot cancel this. All right, supposing that this was a multiplication, they can cancel out. All right, but because there is no multiplication here in between the term you want to cancel out and the remaining term, you can't cancel out. All right, so this will be your final answer. All right, so let me add few more for the example, then before we go into addition and subtraction of algebraic fraction. So I have this problem here. So for the example, for the examples, the first one, 6m squared u squared minus 4m u cubed, this is u, please, over 9m cubed u minus 4mu cubed. All right, so for the example, simplify I, so here I, so under this we have a squared plus ax minus 6s squared all over 2s squared plus ax minus a squared. Okay, so I will tackle these two. So after these two, we go over to addition and subtraction of algebraic fractions. All right. So we have our solution. Solution. So we have the first one, I, which is 6m square u square minus 4mu cube all over 9m cube u minus 4mu cube. Of course, at this point, you can't cancel anything because the sign that exists between the terms in numerator and denominator is a negative sign. It's not a multiplication sign. So we can cancel anything. So we need to factorize here. So we can have a multiplication sign between the expressions, both in numerator and denominator. So that will be our target first. So factorization should be our first step. So let's factorize both the numerator and denominator and see if we can have a common factor. If we have a common factor, we cancel out. If you have no common factor, then we leave the answer the same way it is at the beginning. Okay, let's go. So here we have a common. Okay, let's check the common factor here. 2 is here. 2 is here. So we bring 2 is one of our common factor. So 2 is one of our common factor. 2 is here, 2 is here. Common factor between 6 and 4 is 2. All right? Except 1 now is 2. Then another common factor is m. M is here, m is here. Another common factor is u square. U square is here and u square is here. Of course, u cube is u square times u. So we have common factor of u square. So let's open bracket. So use 2mu square is going to divide each and every of these terms and we write their result here. So let's start with the first one. So we have 6m square u square divided by the common factor, which is 2mu square. Of course, u square cancel out with u square. 2 here, 1, 2 here, 3. M here, 1. M cancel one of the m because m square is m times m. So if I divide by 1m will cancel one of the m, all right? So remaining 1m. So here we have 1m remaining. So at the end of the day, we have 3m left. So 3m is left here. So we have 3m. Now to confirm that you're on the right track, if you multiply 2mu square by 3m, we will get the same 6m square u square. So we can try it. 2 times 3 is 6. M times m is m square. And we have u square left. Okay, so here we have negative sign. So we divide this with this. So here we have 4m u cube all over 2mu square. Of course, m cancel m. Remember that u cube is u square times u. So if we divide u cube by u squared, because u cube divided by u square, then we have u square. So u square cancel u square, remaining only u. So u squared cancel u cube, have only u. 2 here, 1, 2 here, 2. So we are left with 2u, all right? So 2u is what is left, 2 times u, 2u. So here we have 2u. Okay? Remember, to confirm you are on the right track, use this common factor. You use to factorize this and multiply the quotient. So if you multiply this 2mu square with 2u, you will get the same result. 2 times 2 is 4. M times, okay, we have m here. Then u square times u is u cube. All right, so we are done with that. We'll go back to the next one. So we check for what is common. So what is common here and here? Of course, m is here, m is here. So bring out the m. There is no common number there. The only common factor between 9 and 4 is 1. And we don't need 1 in this situation, right? Because multiplication by 1 does not make any difference, all right? So we skip it. So we go back to m. We have already gotten, there is common m. Another thing, common u. So we have mu. So we have common mu. So mu divide 9m cube u. So we have 9m cube u divided by mu. Of course, u cancel u, m here 1, m here, m square. Because m cube is m times m times m. So if we divide by 1m, so 1m cancel 1m, remaining 2m's. So m times m is m square, right? So when mu divide 9m cube u, so what we have is that m divide m cube m square, u cancel u, remaining 9m square. So here we have 9m square. Now to confirm you're on the right track, of course we have 9 here, m times m square, m cube, u is left. Okay, so minus, the sign here is minus. Minus mu divide 4mu cube. So here we have 4mu cube divided by mu. M cancel m. So we have u cancel u cube, should be u squared. Of course, the same thing here, m cancel m cube, we have m squared, the same thing. So u cube is u multiply itself 3 times. So if we cancel 1u, remaining u multiply itself 2 times, which is u squared. So 4 times u squared is 4u squared. So we have done the factorization. At this point, you can cancel any common factor you see if you wish. If you wish, you can still leave it and factorize completely. Then you can now cancel at once. All right? Anytime you decide to cancel, you can cancel. But make sure that before you cancel, there must be an existence of whatever you are canceling. There must be an existence of multiplication between whatever you are cancelling and the remaining terms, both in numerator and what? Denominator. There must be an existence of multiplication between whatever you are cancelling and the remaining terms, both in numerator and what? Denominator. So because there is a mu, and there is a multiplication between them and their what? Remaining terms in both numerator and denominator, of course we can cancel. But here I chose not to cancel. I chose to factorize completely until I begin to cancel. Thank you very much. So let's go. So here we have 9m square, 9u square. All right. So remember that 9 can be written as 3 square and 4 can be written as 2 square. So if we bring this down, we have that this will be equals to 2mu square into 3m minus 2u all over mu into 9 can be written as 3 square. So 3 square m square minus 4 can be written as 2 square. So 2 square u square. All right. So remember, according to law of indices, s raised to power m times y raised to power m, provided they have common power and they are multiplying each other, we can factorize their power as xy all raised to power m. All right. So provided that their power are the same and they are multiplying, we can write the multiplication of the two quantity, put a bracket, and put their what? Their power, showing that their power is being factorized. Right? So power can also be factorized, not only the coefficients or the other neighboring term multiplying. Even powers can be factorized as well. So here we have common power of 2 square between, common power of 2 between 3 and m, common power of 2 here between 2 and u. So we can factorize their common power from the law of indices. So let's continue. So this will be equals to 2mu square into 3m minus 2u all over mu into 3m all square. So I just factorize the square between the square that 3 and m have in common. All right, so I factorize that square. So if I open bracket, to be 3 square m square, which is the same thing as this. Then minus, so I want to also factorize the same square here. So we have 2u all square. Please, this small bracket here is for the factorization of the power. It shows that this power belongs to both 3 and m. And the same thing here shows that the power belongs to both 2 and u. So this one, I open this one, so I have to close it. Okay. So now the next thing is, look at this. Look at this. Take 3m as a simple term. Let me say a single quantity. Let me say k, and take 2u as another single quantity. Let me say r. Of course, if here is k, it will be k squared. If here is r, it will be r squared. So it will be like k squared, r squared, minus between them. This will look like difference of two what? Square. So a term square minus another term square. Of course, I've already told you any difference of two square will be sum of the two terms multiplied by the difference of the two terms. So if we have k square minus r square, so if we have k square minus r square, of course, it's going to be k plus r multiplied by k minus r. So here we are going to assume our 3 to be k, 3m to be k, and 2u to be r. So if we continue further, so we have okay, let me put it here. Let me write it here. So we have 2mu square, all right, into 3m minus 2u all over mu into, this is difference of 2 square, right? So it's going to be 3m plus 2u, all right? 3m plus 2u times, maybe at this point I no longer need this bracket, all right? At this point, I no longer need this bracket, all right? Because I'm about to write this as a multiplication. So difference of 2 square, a term square minus another term square should be sum of the two terms minus multiplied by difference of the two terms. And order is important. So here we have 3m plus 2u into 3m minus 2u. With my experience in this very question, some students misunderstand it a lot because they fail to understand what we mean by 3m and 2u here. Yes, it is true that there are two terms together, 3 and m, but because that they are covered by one square, we can take them as just a single term. Here, you can take it as just a single term. So imagine a single term square minus another single term square is going to be sum of the two terms, which is 3m and 2u, which is 3m plus 2u multiplied by the difference of the two terms, all right? Which is the same 3m and 2u. So we have 3m and 2u under this cos study as our two terms, all right? So it should be sum of the two multiplied by the difference of the two, and that is the complete factorization. So at this point, we can cancel in full. Of course, this and this look alike, so we can cancel. So 3m minus 2u, we cancel out with 3m minus 2u. M we cancel out with m, and u here, we cancel only one u here. We have u. So our final answer, our final remaining terms here is 2u all over. Final remaining term here is 3m plus 2u. No need for the bracket. No need for the bracket because there is no any other term multiplying the term. So the bracket has no need. All right. So you cannot cancel mu, of course, and 2. Of course, you know the reason, because of the positive sign that exists here. So you can cancel. So this will be our final answer. So we go back to the next one, which is II. So we have a square plus ax minus 6x squared over 2x squared plus ax minus a squared. Now, before you play this video, please make sure you have watched my video on quadratic expressions, simplification of quadratic expressions and equations, because this is a quadratic expression, and it takes the knowledge of quadratic expression to understand this. All right, so if you don't have the knowledge of quadratic expression, you'll find it difficult. All right, so we're using the knowledge of quadratic expression to solve it. Okay, let's get started. Of course, we cannot cancel anything here. Obviously, um, it is plus and minus sign existing between numerator and denominator, so we can cancel. So we need to factorize so we can have a multiplication sign between the terms. All right. So we factorize both the numerator and denominator. So can we do that? Of course. So let's factorize. Of course, if I bring the first sample here, the first sample we have the first term, we have a squared plus ax minus 6x squared. Of course, here, if we take x as our variable and take a as our constant, of course, this one with together with this constant will give us product of the roots. All right, so the product of the root there is going to be the constant, which is a square multiplied by this term. And please remember that the negative is also included. So we have minus 6s squared, which is minus 6. A squared times s squared should be a squared s squared. All right, that should be our product of the term. So why the sum is the remaining, the one that has a power 1, that is the sum of them. So we use x as the sum, which is ax. Now our target is two terms such that when we multiply them, it will give us the product of the roots, and when we add them, it will give us the sum of the roots. Please, I told you to understand this better, go and watch my videos on quadratic factorization of quadratic expressions and equations. You will understand better what I mean by these two terms that satisfy both the product and the sum. All right. So how do we find the two terms? Because we need the two terms that will satisfy. When we multiply to give us the product of the root in the expression, and when we add it to give us the sum. Of course, to find the two terms, we are going to find the factors of the product. The factors of the product. And here we are going to use the coefficient. Let's leave the term. Of course, we take x in this context as our variable. So as we are taking s as our variable, we ignore x. So we are only making use of the other terms which are not x. So the other terms which are not x we serve as our constant. Okay. So let's start. So we find the factors of the product. So we are using the constant here as our numbers of evaluation. So we start with minus 6a squared. So let's find the two numbers that satisfy two numbers when you multiply them to give you this. So let's do that. So we have we start with okay. So okay, inside these two terms, now to make it more easier, because that this is also an alphabet, so we are going to skip this one as well. Let's skip it for now. All right, so we skip this one as well. So with coefficient we have left here is minus 6, and the one we have left here is 1. So let's find the factors of minus 6. Two numbers that when we factorize as minus 6. So we have 1 and 2. 2, okay. 1 have entered, sorry, not 1 and 2. 1 divided 6 is 6. Let's use 2. 2 divided 6 is 3. And the next one is 3. 3 have already entered. So we have 1 and 6 and 2 and 3. Now remember there is a negative there. If you say 1 times 6, 6, 2 times 3, 6. So they satisfy both the product. So we are going to find a way to place the negative. All right. Let's place the negative. All right. Now under sum, the coefficient here is 1, because anything that has no coefficient, the coefficient is 1. Remember, I was the one that introduced the 1. There was no 1 here because there was no coefficient as a number here. So we introduce it as 1 because anything that has no coefficient, the coefficient is 1. So we are going to now check if we sum this. Let's find their sum, whether if any of them can give us 1. If any of them can give us 1, then that number, those two numbers will be suitable for this simplification. Minus 1 plus 6 should be 5, right? So minus 1 plus 6 is 5. Then minus 2 plus 3 is 1. Of course, we have gotten it. So it is minus 2 and 3 that satisfy both the product, which is minus 2 times 3, 6, and the sum, which is minus 2 plus 3, 1. All right. Now, assuming that I have minus 1 here and I got 1 at the end of the day, what I will do is that I will switch the sign. All right. Once I switch the sign, I will get negative 1. So we are just lucky enough that when I put the negative here, it satisfies the sum. Sometimes it will be differ by difference of negative 1. So we switch the sign. So when we come to that kind of problem, that kind of situation, I will still let you know. So note that you will not always get it exactly. What you need to concentrate first is getting the actual number, ignoring the sign first. If you get the actual number, if the sign is the problem, then you can switch the sign. If you switch it, you will get your result. Okay. So we have gotten the two numbers that satisfy both the sum and product, which is minus 2 and 3. So what are we going to do? We are going to share the a and x to them. All right. So each one will share the ax because we have ax. We have as in each case. So as. So if we now test it now, so let's test it. Minus 2as times 3as. Of course, we already have negative here. So 2 times 3 is 6. A times a squared, and x times x squared. And this is exactly what we got at the product, which is the product. We multiply the two to get this. So what about the sum? So if we check the sum, we have minus 2ax plus 3ax. This is something as saying 3ax minus 2ax. It's something as saying 3ax minus 2ax. Of course, ax that is 3 in number, you remove ax that is 2 in number. So ax is 3. So remove ax 2 out of it. So it remaining 1 ax, which is ax. And that is exactly what we have as the sum, ax. So the two terms that satisfy both the sum and the product are minus 2ax and 3ax. So we are going to substitute minus 2ax and 3ax with the what? The sum, because the sum is at the middle here. Not necessarily at the middle always, but we are evaluating it by power. So it has a linear power. That is the power of 1. Okay. So we have a square minus 2ax plus 3ax. Remember, these are the two terms that satisfy both the product and the sum. All right, so I'm using this minus 2x and 3ax to replace plus ax, because if you simplify them, minus 2x plus 3ax is still what? Plus ax. So remaining minus 6x squared. And all over, we'll do the same here. So if we do the same here, we'll be left with here our product will be 2s squared times minus as squared. So we have 2s squared times minus as squared, sorry. So we have minus 2 a squared times s squared should be a squared s squared. All right, then that is the product. Remember, the product is the squares multiply, while the sum is the linear, the one with linear power, which is 1. So our sum here is ax. So the coefficient here is 1 and coefficient here is minus 2. So we bring minus 2 here. Remember, we use the coefficient of the product to find the two numbers that satisfy both the product and the sum. Of course, the only two factors that when you multiply them to give you exactly minus 2, or let's ignore this minus 2, is 1 and 2. So you can give anyone the minus. So if I give this one the minus 1 times 2 minus 2. If I give this one minus 2 times 1 is still minus 2. But I choose to give it to 1 because if we check for sum, it will satisfy the sum. Of course, minus 1 plus 2 is 1. So minus 1 plus 2 is something as 2 minus 1, which is 1. And that is what satisfies the sum. So obviously, the two numbers that satisfy both the product and the sum is minus 1 and 2. So in that case, now you're going to give them the terms. We have ax. So give them ax. All right. And minus 1 as. 1 times as is still ax. So this, instead of writing minus 1 as, write it as minus ax, then plus 2ax. If we times these two, to give us minus 2a squared s squared. So can we do that? Yes. So this is minus 2 a times a squared, s times x s squared. So if we do it as a sum, so as that is 2, you subtract one of it, as that is 1, it will remain 1ax. So if we add the 2 to give us as, so these two terms satisfy both the product and the sum. So we are replacing the sum, which is plus ax, with minus ax and plus 2ax. So here we have 2s squared minus ax plus 2ax then minus a squared. All right. So if you want to confirm, when you add these two terms, you still get plus ax. All right. Remember, you always substitute those two terms that satisfy both the product and the sum with the what? The sum. You always substitute them with the sum. The sum is not always in the middle. You locate the sum by checking the power. The power must be linear, which is power 1. All right. And remember, anything that has no power, the power is 1. Okay. So now, in the factorization principle of quadratic expressions, what we do is that we group them 2 by 2. So let's take them 2. So we have 4 terms in each case. So I'll group them 2 by 2. So if we do that, we have a squared minus 2ax plus, we group this one as well, 3ax minus 6x squared, all over the same way we group them 2 by 2, so which is 2s squared minus ax plus 2ax minus a squared. So if we do that, we are going to factorize what is common in each. So let's do our factorization. Of course, what is here and here? There is a here, there is a here. So we'll bring the a outside. A divide a square, a minus a divide 2ax. A we cancel a, remaining 2x. So we have 2x here, right? Plus, what is common here? 3 is common, so bring the 3 outside. And x is also common, so we'll bring the x outside. 3x divide 3ax. 3 cancel 3, s cancel x, remaining what? A minus 3 divide 6 is 2, x divide x squared is what? X. All right? Okay. Then we are done with the numerator, so we'll go over to the denominator. So what is here and here? Of course, x is common, so we'll bring s outside. X divide 2x squared. S, so we have 2 there. S we cancel only 1x here, so we have 1x. Then minus s divide as. S we cancel itself, remaining what? A. Right? We are done with that. Plus, what is here and here? Of course, we have common a here. A is here, a is here. So bring a outside. A divide 2ax. A we cancel a, remaining 2x. Minus a divide a square. A we cancel 1a here, remaining only 1a. To confirm that we are on the right track, if you expand this, you get this, expand this, you get this, expand this, you get this, and expand this, you get this. All right? So that will show that you are still on the right track. So this will be equals to, now we are factorizing completely at this point. We are factorizing completely. Of course, when you check the numerator, a minus 2x, a minus 2x. So to factorize completely means factorize every common term until there is no common term again. So of course there is a common term here in these two. So take this. This term is separated by the plus sign. All right. So this term together with this term separated by what? Plus sign. So in these two terms, there is a common term which is a minus 2x and a minus 2x. So we are going to factorize the common term, which are a minus 2x, a minus 2x. So remember, whatever you are factorizing must be outside the bracket. So the common term here, a minus 2x, a minus 2x. So we factorize it, a minus 2x. So open a bracket. Of course, a minus, remember, whatever you are factorizing outside, we divide each of the term. Remember, this is are the terms separated by a positive sign. So a minus 2x divide the entire term. So we have the entire term here, which is a into a minus 2x. That is the entire term here, divided by a minus 2x. Of course, a minus 2x cancel itself. We are left with a. All right? We are left with a. We are left with a. So what sign is here? Positive sign. Okay? So a minus 2x, which our common factor, we also divide this. So if we have 3x into a minus 2x divided by a minus 2x. Of course, a minus 2x we cancel a minus 2x. So a minus 2x cancel a minus 2x. We are left with what? 3x. All right? And we have factorized it. We have factorized the numerator. Remember, what we did here is that we bring out the common factor, a minus 2x, a minus 2. We put it outside a bracket and use it to divide each of the terms. So if we divide it here, it cancels itself, remaining a. Then what sign is here? Plus. We also divide it here, it cancels itself, remaining 3x. So that's how we got this result, right? So this will be all over. So we have 2x minus a, 2x minus a. So 2x minus a, 2x minus a is common in between these two terms separated by a positive sign. So we bring out 2x minus a. We open a bracket. So 2x minus a divide this. It will cancel itself here. 2x minus a remaining what? X. What sign is here? Plus. 2x minus a will also divide this term. And by dividing it, it cancels itself here. 2x minus a remaining what? A. All right. So at this point, we have factorized both the numerator and denominator completely. All right. Now, is there anything that look alike? Here we have a minus 2x. Here we have 2x minus a. They are not the same. All right. Here we have a plus 3x. Here we have x plus a. They are not the same. But something can be done between these two, because we have 2x, we have 2s, we have a, we have a. The only thing that differentiates them is that here the one that bears negative is a, and here the one that bears negative is 2x. Now I'm going to show you something between two same terms that their sign are differentiated. For instance, a minus b is the same thing as minus b minus a. Let me use a number to prove it. 4 minus 2 is the same thing as minus 2 minus 4. Okay, let's check. 4 minus 2 is 2, right? So here we have minus. 2 minus 4 is minus 2. Of course, any sign outside the bracket is times that which is inside the bracket, right? Minus times minus is plus. So this is 2. And you know 2 is something as plus 2. They are equal, right? So what I'm trying to say in essence is that difference of two number is the same thing as the difference, is something as the negative of the difference of the two number when they are reversed. All right. So difference between two number is something as negative of the difference of the two number when they are what? Reversed. And that is what I just proved here. Any number can work for this. Any whole number at all. If any number can work, any two number can work. No number is exempted in this what? Phenomenon. Okay. So therefore, we can bring a relationship between these two. So therefore, I can say that a minus 2x is something as minus 2x minus a, or I can start with this, or 2x minus a is something as minus a minus 2x. So a term minus another term is minus. You open a bracket, you reverse the term, right? You reverse the term. So the first minus the second. So first minus the second is equal to minus second minus the first in bracket, all right? So that is it. So it's either we replace a minus 2s with minus 2s minus a, or we replace 2s minus a with minus a minus 2s. Anyone you chose to do here, you are still correct, all right? So let's choose. Okay, let me replace a minus 2s. A minus 2s with minus 2s minus a. So which is so wherever I see a minus 2s, I will replace it to minus 2x minus a, because a minus 2 is same as minus 2x minus a, right? Okay, then times a plus 3x. All right, then all over 2x minus a into a plus x plus a. So at this point, 2x minus a will cancel out with 2x minus a. All right. So what is left? What is left is, so this will be equals to minus a plus 3x all over x plus a. Please, if you want to put this negative here, you must put a bracket. All right. Now the minus here is the minus here is used to, in fact, the minus here is telling you that the entire fraction here is being negative. So after you simplify the entire fraction, you attach negative, all right? So if I must put the negative here, then I will put a bracket. I can also put the negative here. But you remember, the standard way is supposed to be this form, because if I have minus 2 over 3, minus 2 over 3 can be also be written as 2 over minus 3. So I can still decide to put the negative at the denominator. But in any of these two, that is not the standard way of writing. Standard way of writing is supposed to be minus 2 over 3. So we now bring the negative sign outside the fraction, right? And then write the fraction on itself, then attach the negative sign at the front, in the middle, right? So that's what I just did now. So I'll attach the negative sign. So this negative sign remaining. And remember, it was this, the what generated this negative sign is trying to make this to look like this, right? So that's what generated the negative sign. So don't ignore it. If you ignore it, you have failed, right? Okay. Sometimes, for example, if there is a negative sign here, we can decide to put the minus inside and change it, all right? There are some cases like that. Okay, so but in this case, the answer is usually in this form. All right. So if you like, you can still interchange this a plus x, because x plus a is something as a plus x. So this can as well be written as minus a plus 3x over what? A plus x, because x plus a is something as a plus x. And that is the standard way of writing it. We are following alphabetical order. And if you check it, it's still the same. Remember, you cannot cancel this a, right? Because of the positive sign that exists here, right? Okay. So this will be our final answer. Okay, so we are going to enter into addition and subtraction of algebraic fractions. Addition and subtraction of algebraic fractions. Addition and subtraction of algebraic fractions. So example, simplify the following fractions. So simplify the following fractions. All right. Four over 5d plus 7 over 3e. I 4 over x minus 6 over x plus 2. So I x plus 4 over x squared minus 3x minus x minus 1 over 9 minus x squared. Okay, so IV 1 over a minus 2m minus 2 over a plus 3m. Okay, we have V, we have 2 plus 6a square plus 2b square over 3ab minus 4a minus b over 2b. All right. Right, so let's make it 6. So vi have 1 over 4 into u minus v and minus 1 over vi 1 over 4 into u minus v minus 1 over 5 into v minus u. All right, so we are going to consider these problems. So we start from the first one, I. So our first one here, I, is 4 over 5d plus 7 over 3e. Remember, this question is called algebraic. This question is a problem of algebraic fractions, all right? First, so you use two knowledge to solve it, knowledge of fractions and as well as knowledge of algebra. So we are applying the same knowledge, all right? So when you are adding fractions, of course, one of the things we do is that we find the LCM of the denominators of the individual fractions. So the LCM of 3d and 5e. Remember, whenever numbers have no common factor, the LCM will product of all of them. There is no common factor here. In fact, we are not adding 1 because multiplication by 1 does not make a difference. Remember, in factor, multiplication is what we use to evaluate factors, right? So if 1 is involved, then that 1 makes no difference, all right? So we don't use 1. So we use other factors that are not 1. So the only factor between 3d and 5d and 3e is 1. So we don't use it. So therefore, since there is no common factor here, we multiply them entirely. So 5, so the LCM will be multiplication of both entirely. So 5 times 3 is 15, and d times e is de. Okay, so let's go there. 5d divide 15de, so 15de divided by 5d. Of course, our final answer will be 3e. Remember, it is these two things that you multiply to get this. So if you use one of them to divide, you get the remaining. Or if you like, you can still do it 5 here 1, 5 here 3, d cancel the remaining 3e, right? So the 3e which is remaining will multiply 4. So 3e times 4, 3 times 4 is 12. Remaining what? E. At this point, if you don't understand, go and watch my videos on fractions, right? So simplification of fractions. So we are using the knowledge of fraction right now. So the next one is plus sign. The plus sign that is here. So 3e divide 5de. All right, 5de divided by 3e. Of course, we get 5d because it's 5d that will multiply to 3e to give us 15de, right? So, or you can do it in a simpler way. In the other way, 3 cancel 15, 5, e cancel e, so have 5d. So 5d, which is what is left after 3e divides the LCM 15de. So the 5d that remains, we multiply it with 7. 5 times 7 should be what? 35, right? The remaining d, so 35d. So this will be our final answer. We have added two fractions. All right, to be our final answer, there is nothing to cancel. Yeah, is there? No, there is. There is nothing. Of course, these two things have no common factor. The factors of 12 apart from 1 is what? 2, 3, 4, 6, and 12. While the factors of 35 apart from 1 is is 5, 7, and 35. All right? 5, 7, and 35. Thank you. So there's no common factor. So our final answer is this. So E cannot cancel, D cannot cancel because of positive sign separating them. So that's our final. So we'll go back to the next one. I. We have 4 over x minus 6 over x plus 2. So we find the LCM of x and x plus 2. Of course, remember, two of them are separate. Please, x plus 2 is not a factor of x. All right? It's just like saying that 2 is a factor of 2 plus 3 because they have common 2. No. 2 plus 3 is 5. All right? So 2 is not a factor of 5. All right? So that is one thing I want you to know. So they are not a factor. So the only way that x would have been a factor of x plus 2, okay, there's no guarantee way now, except if x is 0. If you say that if x is if both x and the x here are multiple of 2, at some point it will violate. So for now, whenever you see this kind of thing, they have no common factor. Just assume that they have no common factor. So the LCM will be the product of the 2. All right? Because if we say let us solve it the way we solve LCM, so put it separately. So of course, the first thing that will go is x. X divide x, 1. X cannot divide this one. All right? So we'll bring down x plus 2. So the next thing is x plus 2. This one is already 1. So x plus 2 cancel, x plus 2 is 1. So the LCM is this times this. So it's just like taking them that they have no common factor. So the LCM will be product of the 2. So and the product of the 2 is x into x plus 2. So let's put it in a factorized form. This times this, that is like this. All right. So that will be our LCM. So this divide this, x will cancel itself, remaining x plus 2. X plus 2 times 4 should be 4 into x plus 2. What sign is here? Minus. This divide this, x plus 2 cancel x plus 2, remaining x. X times 6 to be 6x. So if you open a bracket here, open a bracket, 4 times x, 4x. 4 times 2, 8, minus 6x. All over x into x plus 2. So 4x minus 6x should be minus 2x, all right? So this will be equals to 4x minus 6x. So collect like times. 4x minus 6x is what? Minus 2x. And what's remaining here? Plus 8. Then all over x into x plus 2. So which is now, in mathematics, it is advisable we start with positive terms than negative term. All right? We start with positive term than negative term. So let's start with positive term, which is 8. So we have 8 minus 2x. Now, if you like, you can leave the denominator like this. But in most cases, since you have done with your simplification, you can put it back. All right? You put it back, x times x, x squared, plus x times 2, 2x. So that should be our final answer. There's nothing to cancel out. There's nothing to cancel. You can't cancel the 2x out because the sign that is using between these two are positive and negative. All right? And and because you can also factorize, assuming that we can factorize something common here out, of course we can still cancel further. All right, so we can cancel further. So this will remain our final answer. So we'll go back to the next one, which number 3, I x plus 4 over x squared minus 3x, then minus x minus 1 over 9 minus x squared. So we look for the LCM. But before we look for the LCM in this situation, let us first of all factorize each of the term. All right. So if we factorize each of the term, so here will be x plus 4 over what is common here, x. So bring s outside the bracket. S divide s squared, x minus s divide 3x. S cancel x remaining what? 3. All right. If you expand x times s squared, we have minus here, x times 3, 3x. So here we have minus x minus 1 all over. So here this will turn into difference of 2 square. Of course, this 9 can be written as 3 square minus s square, because 3 square is 9. All right. Okay. So this will be equals to, now if you look at this point, now let's use a common sense here. When if we do this as difference of 2 square, we have 3 plus x times 3 minus x. But meanwhile, instead of having 3 minus x, we have here x minus 3. So how do we bring x minus 3 here? By factorizing this minus. So we are going to factorize it so we can have x will come first, because here x come first. So we need to make x here to come first. All right. So we can get a result like this. It's a common sense. Math is all about applying common sense. All right. So if we can get something like this here, of course, the two of them will act as a common factor. So we only pick one. All right. So let's use the principle I have initially initiated by a minus b is the same thing as what? Minus b minus a. So here, 3 squared minus s squared is something as minus s squared minus 3 squared, right? So s squared minus 3 squared. So we are going to factorize it, interchange this, and to make it the same, we bring out negative sign, all right? So if we do that, we have x plus 4 over x into x minus 3, then minus x minus 1 over, we'll bring out the minus, so minus s squared minus 3 squared. So of course we can take this minus up here, all right? Remember that minus 1 over minus 2 can be written as minus, we can take the minus up here, minus 1 over 2, which is minus is what? Plus 1 over 2. So you can try your calculator. Minus 1 over minus 2 should be positive 1 over 2, or positive half. All right, so we can do the same thing here. So this will be equals to x plus 4 over x into x minus 3. All right, so we'll bring out the minus is plus. So we have plus x minus 1 all over x squared minus 3 squared. All right, so no need for the bracket, because I have already taken out the negative sign that that brought about the bracket. So the bracket insinuating that negative sign belongs to both of the number. All right, so bear it in mind. At this point, we will break this further so we can get a result like this. So when we do that, we have that this will be equals to x plus 4 over x into x minus 3 plus x minus 1 all over. Okay, let me enlarge it. So we have x minus 1 all over difference of 2 squared. So it will be sum of the two, which is x plus 3, then multiply by the difference of the two, which is x minus 3. All right, that is difference of 2 squared. So whenever you see a term square minus another term square, it is called difference of 2 square. Difference of 2 square. So it should be the sum of the two terms multiplied by the difference of the two terms. And order is important. The first will always be the first to avoid error. All right, not necessarily on the one that carries positive, but on the one that has negative. So that's why you must follow order. Okay, so that's it. So now this is a time for bringing them together. So of course our LCM is going to be, we have common x minus 3, x minus 3. So among these two, we can only pick one. All right, so we pick one. So these two things has nothing in common. So we pick them separately. So we pick x. All right. So these two now, one we represent one of them. All right, so we pick one of them, which is x minus 3. So the remaining is x plus 3. So we add x plus 3. I hope you understand this. Now, if you don't understand, let me explain again. We want to find the LCM of 1, 2, 3, 4. All right. Now, anyone that has any common term can always be represented by one of the term. Right. So we have common term here, x minus 3 is here. So 1 x minus 3 can represent the both, all right, because they are LCM of each other, all right. So it's the LCM of each other. So we pick 1 x minus 3. So what is remaining apart from these two? So this x minus 3 has represented the two of them as the LCM. Now what is remaining is x and x plus 3. So they have nothing in common. So the LCM will be product of the two, which is x multiplied by x plus 3. So that is the wisdom. So these three terms has represented the entire term. All right. So let's go. So we divide. This divide this. So we have x, we cancel x minus 3, we cancel x minus 3, remaining x plus 3. So the x plus 3 will multiply whatever that is left on the numerator. So we have x plus 4 multiplied by x plus 3. And we have plus. Then this we divide this. So of course x plus 3 cancel x plus 3, x minus 3 cancel x minus 3, remaining what? X. Remaining x we times this x plus 1. The plus is coming from here, I hope you know. So the remaining x multiply x minus 1. So we have x into x minus 1. So at this point we expand. So we expand. Oh, I have cleaned the problem. Okay, don't worry, we know what to do. So if we expand to have that this will be equals to, of course, if you expand this, we take x into this, or shall we do it somewhere here? Okay, let's do it somewhere here. Take x into this, so we have x into x plus 3, then plus 4 into this, we have plus 4 into x plus 3. So if you don't understand very well, go and watch my video on expansion. All right. So if you want to multiply two binomial terms, these are binomial terms having two expressions combined together. So anyone can multiply anyone. So if I'm using this one, the part of the term will multiply the entire term, and the remaining part will also multiply the entire term, and vice versa. So, and we have done that here, x into x plus 3, then plus 4 into x plus 3. All right. So so far that the entire part has multiplied this, then we have to do the multiplication. Then plus, this is only one term. X times x is x squared, plus times minus is minus, x times 1 is x. All over. No need of expanding this, all right? Just put it in that factorized form, which is x into x minus 3 and x plus 3. So if we open a bracket, if we open bracket there, x times x is x squared. So here we have x squared, all right? So plus x times 3 is 3x. We're done with that. So we have plus 4 times x is 4x plus 4 times 3 is 3x. So let me check if we are not making any mistake. All right. Okay. Okay. This cancel this. Okay. We're not making mistake. Okay. So 4x then plus 4 times 3 is 12. All right. 4 times 3 is 12. Then plus s squared minus x plus s squared minus x, then all over. So we can check it. S squared 3x, 4x, 12, 4 times 3, 12, x squared and minus x. Okay, all over x into x minus 3, then x plus 3. So if we simplify further, x squared plus x squared is 2x squared. 3x plus 4x is 7x. Then plus what? 12. All over. No, before we forget, this is minus x, right? 7x minus x. So this is supposed to be 6x. 6x, all right? It's supposed to be 6x because if we say 4x minus x is going to be 3x, 3x plus 3x is x, or 3x minus x is 2x, 2x plus 4x is x. So anyway, so we have plus 4. Okay, so we have x into x minus 3 and x plus 3. So at this point, we can, of course, factorize the 2. We can factorize 2. So 2 is common, so put 2 outside bracket. 2 divide 2x squared, x squared, plus 2 divide 6x, 3x, and plus 2 divide 12 should be 6. Then all over x into x minus 3 into x plus 3. So we can factorize this quadratic expression. So if we do that, our product of the root is x squared times 6, which is 6x squared. Sum of the root is 3x squared. So two terms that will satisfy both the product and the sum. So we use 6. So we have 1 and 6, 2 and 3. Right? So which one will give us 3? Is there anyone that will give us 3? Of course, none. None. None will give us 3. None will give us 3. Yeah. None will give us 3. So because that there's no way that we can simplify these two terms and have 3 here as the sum. All right? There's no way we can sum them and have 3. So the factorization cannot work. All right? It can't go. All right? So it can't go. I have checked it now. So 1 plus 6 is 7. 7 is not 3 here. 2 plus 3 is 5. 5 is not 3. So the factorization cannot go. So we can leave the final answer this way. So our final answer, let's leave it this way. 2 into x squared plus 3x plus 6 all over x into x minus 3 into x plus 3. So that should be our final answer. All right? So we go back to the next question. This one is II. So our IV, I've forgotten, I didn't arrange it. I don't know. So I'm going to just consider anyone I see as our IV. Right? All right. So let me consider this one as our IV. IV, let me consider 1 over A minus 2M minus 2 over A plus 3M. Okay, so our V, okay, and VI is this one, number 13. Okay. So for remembrance sake, all right, so let's solve this problem. Okay, so here we look for the LCM. Of course, these two things have nothing in common, right? Yes, they have nothing in common. Don't use because of this A to say they have something in common. The positive and negative sign between the term has cancelled everything. Assuming there is multiplication, we would have said that A is common, right? So the LCM will be product of the 2. The product of the 2 will be LCM. So which is A minus 2M. Once there is no common factor between the 2 or more terms you are looking for their LCM, their LCM will be product of all of them. So we have A minus 2M times A plus 3M. So when this divide, a minus 2m cancel a minus 2m, remaining a plus 3m times 1 should be the same a plus 3m. Then what sign is here? Minus. A plus 3m divide the entire LCM, so it cancels itself, remaining a plus 2m times 2. So it's going to be 2 into a plus 2m. No, not a plus 2m, a minus 2m. Because this cancels this, we have a minus 2m times 2, so 2 into a minus 2m. So this will now be equals to, we open bracket. If you open bracket, we have a plus 3m minus 2 times a is minus 2a. Minus times minus is plus. 2 times 2 is 4. What is remaining there? M. Then all over a minus 2m into a plus 3m. So if we simplify further, we have 3a plus 4a is 7. 3m plus 4m is 7m, right? A minus 2a should be minus a. So 7m over minus am, 7m minus a. Remember, I collect like terms. 3m plus 4m, 7m. A plus minus 2m minus a. Alright, you are trying to remove 2a from 1a. So when you remove the first one, remaining 1 to be removed. So the negative shows 1 to be removed. So we now have a minus 2m into a plus 3m. So I think that is our final answer. So 7m minus 2m to a. Because there is nothing to cancel out. Alright? There's nothing to be cancelled out. So that will be our final answer. So we go back to the next one, which is number V, 2 plus 6a square plus 2b square over 3ab minus 4a minus 4 minus b over 2b. Okay, so this will be equals to, all right, so here we look for the LCM by making this over 1. So our LCM is, yes, we have common factor. These are product, they are multiplying themselves, so b is common. So we take 1b. So we have 2 times 3a, which is 6a, because these two things has nothing in common, so we multiply them. So if we exclude b, leave b aside, these two, 3a and 2, has nothing in common, right? So because they have nothing in common, the LCM will be product of the two. So 3a times 2 should be 6a. So remaining what? B, right? So that b, because they have it in common, we pick only 1. 1 divided by 6ab should be 6ab. So 6ab times 2. So 2 will times 6ab. 2 times 6 is 12. Then we have ab. Alright? So plus 3ab divides 6ab. A cancel a, b cancel b. 3 divided 6 is what? 2, right? So it's 2. So when we now use that 2 to expand the numerator, so have 2 into 6a square plus 2b square. All right. So here we have a negative sign. Okay. So 2b we divide 6ab. B we cancel b. 2 cancel 6 is 3. So we have 3a. So 3a we times 4a minus b. So have 3a we times 4a minus b. So let's cross check if we are still correct. Okay, at this point we say we have this as our problem to solve, so we want to bring them together. You know, one thing about adding or subtracting fractions is to bring the fraction, is to make the entire fraction a single fraction by bringing them together with their respective signs. All right. So, and how to do that? First of all, find the LCM. So with the LCM, you can bring everything together. So here we say 1 divides 6ab. It is 6ab. So 6ab times 2. Just like this, we want to multiply by 2. So it's going to be 12ab. All right. That's what we have here. Then this divide this. 3 cancel 2. Right. And AB cancel AB. So we have 2 left. So that 2 will multiply this term, which is 6a squared plus 2b squared. All right. Then remaining 2b will come and divide. B cancel B. Then 2 cancel 6 is 3. So remaining 3a. So 3a will come and multiply the numerator, which is 4a minus b. So if we continue, we have 12ab plus open bracket 6 times 12. 2 times 6 is 12. So we have 12a square. Plus is still plus. 2 times 2 is 4. So it's 4b square. Right? Open a bracket here. Minus times plus is minus. 3 times 4 is 12. A times a is what? A square. Minus times minus is plus. 3a times b is 3ab. All right? So all over 6ab. So we'll continue with our simplification. So here we simplify the numerator. So have AB, AB. So have terms in AB, terms in AB. Okay, and we have, okay, plus 12a square cancel with minus 12a square. Okay, so 12ab plus 3ab should be 15ab. So this should be 15ab plus 4b square all over 6ab. All right. So of course there is something that is common here. B and B are common. So we bring the B outside. Right. So we bring B. You have B into B divide B here. We remain 15a plus B. We cancel one B here. We have 4b. All right. All over 6ab. Of course B we cancel B. So we are left with 15a plus 4b all over 6a. All right. Okay. So that should be our final answer. Yes, there's nothing to cancel out. Actually, we have already canceled out any possible thing that needed to be canceled out. Okay, so that should be our final answer. So we go back to the last question, which is VI. VI. So in VI we have 1 over 4 into u minus v, then minus 1 over 5 into v minus u. All right. So in this case, we have solved a problem like this before, whereby this we have two terms that look alike. It's just that they are swap of each other, separated by negative sign, such that one is a reverse of the other. All right. Now, if you want, you can transform this. You have negative, you can transform this to be v minus u. This is u minus v, and this is v minus u. You can transform this, but if you have negative here, you will get the same answer, but it will take more, I mean, it will become a little more stressing. So to make it more simpler, we transform this so that we can make the two negative to be positive. All right. So you know already that v minus u is minus u minus v. All right. Now this is v and this is u. So and this is u and this is v. All right. So we are going to replace v minus u with minus u minus v. I mean minus into u minus v. So if we do that, we'll be having that this will be equals to 1 over 4 into u minus v, then minus 1 over, so this will be 5 minus, okay, let me put it this way, 5, let me put it this way, minus 5 into u minus v. Please, the minus u minus v replaced v minus u, all right? So we have 5d already. So don't be confused with, if I put the minus here, 5 will look somehow. So I just want to, put the sign before the number, right? So bear it in mind that it's supposed to be minus u minus v. That is this replacement of v minus u using this what? This knowledge, all right? Okay, so understand it. So this is the 5, v minus u is sent as minus u minus v. So that is it. So if we do that, we can carry the minus here. Minus minus is plus. So we'll be left with 1 over 4 into u minus v plus 1 over 5 into u minus v. All right? So of course, we look for the LCM now. We have already common u minus v, so we look for the LCM of 4 and 5. So 4 and 5 have no common factor, so the LCM will product of the two. 4 times 5 is 20, all right? So because that these two things are the same, so the LCM will be one of them, all right? So we'll pick one of them, and if we pick one of them, it's going to be u minus v. Somebody asks, where did I get this positive? Please, it is the minus I brought out here. Minus times minus is plus, because if I take this minus here, it will be minus minus, which is what? Plus. So that is where the positive sign comes in. All right? Okay, that is by the way. So this is time we simplify further. Of course, 4 u minus v divide this. U minus v cancel u minus v. We have 4 divided 20 is 5. 5 times 1 is 5 plus 5 divided 20 u minus v. 5 u minus v divided 20 u minus v. U minus v cancel u minus v. 5 divided 20 is 4. 4 times 1 is 4. So this will be equals to 4 plus 5 plus 4 is 9 over what? 20 u minus v. So our final answer is 9 over 20 u minus v. So if you don't see it clear there, our final answer is 9 over what? 20 u minus v. That is our final answer. And another way you can confirm if your answer is correct. If you want to confirm if your answer is correct, look for any number to attach u and v. All right, so let's make it easier. Let's give maybe one of them 0 and one of them 1. So let's give u 0 and let's give v 1. All right, so if we do that, we have that 9 over 20 into, so our u is 0 minus our v is 1. So at the end of the day, we'll be left with 9 over 20 times 0 is 0. Of course, 0 minus 1, it should be 20 into 0 minus 1 is minus 1. All right, this is 9 over 20 minus 1 is minus 20, which is minus 9 over 20. So if we use u as 0 and v as 1, we'll get this entire expression as what? Minus 9 over 20. So we can put it here and know whether if we get the same result, minus 9 over 20. If we get the same result, that means the entire fraction here is the same thing as this. So let's try it here. So this should be 1 over 4 into, our u already is what? 0, minus our v is 1, then minus 1 over 5 into, our v is 1, minus our u is 0. Okay, so at the end of the day, we are left with 1 over 0 minus 1 is minus 1. So it should be 4 into minus 1, then minus 5 over 1 minus 0 is 1. 1 times 5 is 5. So this should be 1 over 4 times minus 1 minus 4 minus 5. So the LCM of these two things, okay, I can put the minus up here. Now remember, if you have minus at the denominator, you can put it at the numerator. LCM of 4 and 5 is 20. 4 divided 20 is 5. All right, 5 times minus 1 minus 5. What sign is here? Minus. 5 divided 20 is 4. Okay, 4 times 1 is 4. So this is minus 5 minus 4 is minus 9 over 20. So that is something we got here, minus 9 over 20, minus 9 over 20. So you can see that these two things are the same. So whatever you call your u and v, provided that it doesn't make the denominator here 0, it will always give you the same result when you substitute the same thing here. All right, so that shows that both of them are equal. So the simplification of what we just did right now is that this is equals to this. That is the simplification. That's another way you can test if what you are doing is accurate. So we are going to go into the next phase. The next phase is going to be multiplication and division. All right? Multiplication and division of algebraic fraction. Multiplication and division of algebraic fraction. Okay. Example, simplify the following. Simplify the following. So our I, a squared plus 2a minus 3 over a squared minus 16 times a plus 4 all over a squared plus 8a plus 15. All right? Plus 15. So our II, m squared minus a squared over m squared plus bm plus am, then plus am, then plus ab, then divided by m squared minus 2am plus a squared divided by cm plus bc. All right. So I'll put up 3 questions. Then we have a square plus ab all over a square minus 2ab plus b square divided by a plus 3b over a plus 2b times ab minus a square all over a square plus 3ab plus 2b square. All right, so let's get started. Okay, so we have solution. So the first one in our course study here is a squared plus 2a minus 3 all over a squared minus 16 times a plus 4 all over a squared plus 8a plus 15. So this will be equals to Now, because this thing has to do with multiplication, there's no need of looking for LCM. We only look for LCM when addition and subtraction of fractions are involved. But when we are dealing with only multiplication of fractions, there's no need for the LCM because we can cancel from any angle, provided we have done our factorizations that both the numerator and denominator are in multiplication form, right? So both the individual expression in numerator and denominator are in multiplication form. So provided that they are in multiplication form and there is multiplication that exists between them, we can cancel from any place, provided we have common factors. All right, so let's we are going to factorize this, then we will see what we can be able to cancel. So let's get started with this one. So if we are to factorize a square plus 2a minus 3. Of course, here is the product and here is the sum, right? So our product is a squared times 3 minus 3a squared. Our sum is plus 2a. So we have two numbers. If you times them, it will give you minus 3. If you add them, it will give you plus 2. So we look for the factors of minus 3. So have 1 and 3, and that is all. All right? So which one are we going to give negative? So we can have plus 2, right? Of course, if we give 1 negative, we have plus 2. Minus 1 plus 3 is plus 2. That is the sum. If you sum the 2 to give you what? Plus 2. But if you multiply the 2 to give you minus 3. So minus 1 times 3, minus 3. Minus 1 plus 3, plus 2. All right? So the two numbers that satisfy both the sum and the product is minus 1 and 3. So because they have attached a here, so we attach a to them. So we have 1a is a, right? So minus 1a is minus a, and 3a. So minus a plus 3a will give us plus 2a, right? So minus a plus 3a will give us plus 2a. While minus a times 3a will give us minus 3a squared. A times a is a squared. We have minus 3. So you see that the two terms that satisfy both the sum and the product is minus a and 3a. So we are going to replace it with the sum, right? So if we do that, we have a squared plus, okay, is it plus? Is it plus? No, we have minus a here. Of course, plus minus is minus. So we have minus a. We are replacing this with minus a and what? With minus a and 3. So we have minus a, then plus what? 3a. So minus a plus 3a will give us plus 2a, right? Then we have minus 3 here. Then all over. Of course, this is, we can write this a square minus 16 can be written as 4 square, right? Okay, so times, because 4 square is 4 times 4, which is what? 16. All right, so we have a plus 4 all over. So we also factorize this. So if we factorize it, our product is a square and 15. A square times 15 should be 15a square. Why our sum is 8a, right? So we have 8a. So let us go and find the factors of 15. So this is 15. We have 1 and 15. We have 3 and 5. Of course, this is far. 1 plus 15 is 16. But 3 plus 5 is 8. So these two is more suitable. These two satisfy both the product and the sum, right? So 3 plus 5 is 8, and 3 times 5 is 15. All right? I told you earlier, if you don't understand it very well, watch my videos on quadratic fraction, on quadratic expressions and equations, you will understand better. So now we will attach a to them, so we have a. So of course 3a times 5a is 15a squared. A times a squared. 3 times 5 15. Why 3a plus 5a is 8a. So we are going to replace these two things with the sum, right? So this will be a squared plus 3a plus 5a. Remember, they have no sign, so their signs are positive, all right? Plus 3a plus 5a, then plus what? 15. All right? So we factorize completely. So this will be equals to, we group them 2 by 2, so we have a square, minus a plus 3a minus 3 all over difference of 2 square, which is a plus 4 into a minus 4. Then times, this is a plus 4 all over, we group them 2 by 2, which is a square plus 3a, then into plus plus 5a plus 15. All right, 5a plus 15. So this will be equals to okay, let's factorize. What is common? A is common. So we bring out the a outside. A divide a square, we have a minus a divide a. A divide a square, we have 8, yeah? Then a divide a, we have 1, right? Okay. So plus sign. So what is here and here? 3 is common. So bring out the 3. 3 divide 3a. 3 cancel 3, remaining a. So what sign is here? Minus. 3 divide itself, here we have 1. Remember, anything divide itself is 1. Alright? All over. So this is a plus 4 into a minus 4. Then times, here we have a plus 4 all over. So we also factorize. A is common. So I have a plus 4. So a is common. A is common here. A is common here. So we pick a outside. So a divide a square. All right. All right.